FRQ, and it covers a topic in AB, which was area under the curve, but it also includes volume, which is briefly mentioned in Part C. We're going to use integrals to find the area under the curve and go through why we use the formula we use to find this area. We're also going to mention common mistakes that students might make when they approach a problem like this. Okay, so jumping into problem A, we are trying to find the area, and we're given the c value of this y equals cx squared 4 minus x squared. So we're going to write that out, put in the 6 for c. And essentially what we're doing is we're just finding a bunch of rectangles, as drawn on the right, and we're basically finding the area of each of them and then just adding them up. That's what an integral does. So we're going to set it from 0 to 2. Our 2 comes from the y function. When x is 2, it's going to be y 0, and it's bound by the first quadrant, so that's why we do that. So now here we can do a u sub because we got x squared and x. So we're going to set our inner or x squared higher term as u, and we can derive that, so we get negative 2x. And now we're going to get it into terms of u. So rewriting our integral from 0 to 2, we have 6x times root u since we replaced it, and here's where the x's cancel. There's still a coefficient negative 3, and here we're not going to add any boundaries because it's in terms of u. We can either solve for the u boundaries, but we're going to convert it back into x later. So for now we have u to the 1/2, which is using the reverse power rule. That's how we integrate it. We can just add 1 to the power, and then it's over 3/2. So we get 2/3 u to the 3/2. So now we're going to put that in. And there are no boundaries because it's an indefinite integral. Cancel the 3's, and now we're going to write it in terms of x. We're going to replace the u. So we have our u term in terms of x, and we're going to cube the inside. So now we use the fundamental theorem of calculus to evaluate what this is, and we can bring back our terms. We can cancel the 2's because it's 4 minus 4 is 0, and at 0 we have 4 cubed, but in the square root, which is 8. So negative 2 times negative 8 is 16 inches squared, and they're inches. Okay, so looking back at this problem, you're given a point for setting it up right, anti-deriving correctly, and then getting the right answer. A common mistake is either setting it up wrong with maybe the bounds, not choosing 2, maybe you subbing it incorrectly and not getting a negative, which changes the answer, and the biggest mistake is probably having incorrect bounds when you are in terms of u. Usually you can just put 2 and 0 into the u function to get your bounds, or you can just not write any bounds, and then once you put it back into terms of x, that's when you add bounds. And since it's in inches, you need inches squared. Okay, so jumping into part B, we are given the dy over dx function of the y function, and we're also given the largest radius, which is going to be the max of the function. We are finding the value c to make sure 1.2 is the max radius. So now we're going to set dy over dx equal to 0, since if we draw like a tiny little graph, at that top the slope is going to be 0. So after we set 0 equal to the big derivative, we're just going to solve for x. So we have c of 4 minus 2x squared over square root of 4 minus x squared. We can multiply the 4x, the bottom term, and that just eats up with 0. And now we solve for x, and basically we just set it equal to the inner because we're just solving for x. So now after doing simple algebra, we can find that x squared equals to 2, which means square root of x squared, or x equals to root 2. So now this isn't obviously the final answer, it's just that when x equals to square root 2, that's when the radius is the largest. So we plug square root 2 into the x or y, x for the y function, Now we're going to rewrite the y function, y equals cx to the 4 minus x squared. And here is where we plug in the square root 2, so we're going to keep c the same because it's a constant. And now we have 4 minus x squared, that should be a square root 2. The reason we do this, as the line I drew on the graph, that is x, that's root 2 on the x-axis, and that's the largest radius of the function. So now we're going to write y equals to c times root 2 times 4 minus square root of root 2, which is 2, so 4 minus 2 is 2, which just cancels 2c, and y is going to be the radius since it's the function. 1.2 is equal to 2c, c is 0.6, and since it's a constant, there are no units, so that is the value of c. So looking back at question B, we can see some common mistakes might not be knowing like what dy over dx is in the context. That's just when the slope is 0, there's a max like written over here, and you can also tell with the graph right here that's 0. After that, it's just simple algebra, maybe not getting root 2. Then you gotta plug in root 2 into the function, and then y, you have to set that equal to 1.2, even though it doesn't deliberately say that's the y value, and you get 0.6. You don't need to add units because c is a constant as mentioned at the start of the problem. Quick thing to add is that College Board didn't deduct any points if you don't prove that x equals root 2, but you should probably do so. Here's the math, this is positive, negative. You can also see the slope is positive here and negative here, and here's your explanation down here. So that's how you do it. C, we're given that the volume is 2 pi cubic inches and we need to find the value of C. So we're given like the general formula for the volume between two curves, and we can find that out by drawing a bunch of cylinders. The volume of a cylinder is pi r squared h, where pi is the pi in the front, h is just the Riemann sums a bunch of times, and the r squared is the f of x squared minus g of x squared. But g of x is just 0, so we can just do f of x squared and cancel the g of x squared. So now we have pi from 0 to 2, since it's the same bounds, of f of x squared dx. And now we're going to put in our y function into that, and we're going to square that. So now, after doing that, we should get v equals pi 0 to 2 of c squared times x squared times 4 minus x squared, since the square root cancels out. We can move the c squared in the front because it's a constant and not in terms of x. So now we're going to figure out how to integrate it. We can do so by foiling the x squared into the 4 minus x squared, so we get two different terms, both in terms of x, and then we can do the reverse power rule, which makes it pretty easy to integrate it. So now we're going to write 4x squared minus x to the fourth, and now we're going to bring that up to the top, and we got v equals pi c squared from 0 to 2, and we're going to evaluate, so that's 4x cubed over 3 minus x to the fifth over 5, just reverse power rule, of 0 to 2. As 0, since both terms have x, it's just going to be 0, and now we're going to plug in 2, so we should get 32 over 3 minus 32 over 5, and we want this in one term, so v equals pi c squared. This is where we put into one term. We get 160 over 15 minus 96 over 15, which is 64 over 15, and this expression is going to equal to the volume, which is 2 pi, so we can just set 2 pi to v. And now we solve for c. We can cancel our pi's on both sides and bring over the coefficient, and we should get 30 over 64, or 15 over 32 equals c squared, square root both sides, and it's a constant, so square root 15 over 32 is just the final answer, nothing else. So for part C, to better explain kind of what we did at the start, it was a little fast. This distance right here is r, and we're going to square it since it's a bunch of cylinders. Obviously the pi is there. The h is going to be this distance here, like in between these areas. Basically we're trying to find infinitesimally small cylinders, so it's like really skinny. Now to the scoring guidelines, you get a point for setting your integral right here. For taking out the c squared for evaluating it correctly and anti-deriving it correctly all here, and finally getting the right answer. Maybe a common mistake is not taking the c squared out. Since it's a constant, it might be hard as it is a variable c squared, but you can take that out. Anti-deriving it by maybe foiling it out, and then maybe just some algebra error, probably right here because it's big numbers. But after that, you should get c equals to the square root of 15 over 32. And remember, there's no units because we're solving for a value of c, not any term of c. It's just a constant. So that's how we do it.